So as a reminder for those who have just joined in the series, we are recording this for our YouTube channel. If you're new or just walked in, we're going to be moving fairly quickly. Please watch the previous videos in the series to understand some of the navigation and tools on how they behave. We're going to be doing a complete job build with the assumption that you have been with us for the entire workshop and are already familiar with the concepts that we have covered so far. So in this particular exercise, we're going to be doing a full job build on a set of assorted drill bits, and we're going to be using a standard resolution 7600 series camera from Cognex. So I'm going to pull back over my EasyBuilder programming environment. And with this, we need to get set up to be able to work with this new set of images. So if I come under the Get Connected, and with the Get Connected, I'm going to go to my emulator, and I'm going to change camera series. This previous exercise used the 9912. We want to use the 7600. Now there are several options. I want you to choose the 640 by 480 resolution. Do not choose the color one, choose the monochrome one if you are following along with your copy of Cognex Insight Explorer. Now I'm going to hit OK. It asks me, do I want to save this job? And I'm going to say no. So if you are new to the series and you're just joining us at this portion and you do not have a copy of Cognex Insight Explorer, you can download that from the Cognex website. You will need to activate the offline emulator key. In our first video of the series, we did go over how to get that key downloaded, how to set it up, and how to be able to activate it to work with a series of recorded images. All right, so now my emulator has loaded in the correct characteristics for the camera that we're going to be working with, and now we need to pull in our series of saved images. So if I come under the tab Setup Image, Load Image from the PC, I'm going to come to my Image Navigation button, and I'm going to choose a set of images called drill bits and say OK. So now I've loaded in my series of images for these various drill bits. So what we need to do, a couple things. We need to count the number of drill bits to make sure that we have the right number present, and we need to measure them to make sure that we have the correct size. So to do this, since it is a full job build, first place I'm going to go to is I'm going to go to my Locate Part, and I'm going to choose my PatMax pattern tool. If you're not familiar with PatMax, another video in this series on our YouTube channel does cover the PatMax pattern matching algorithm and the power that's associated with it. So please refer to it for more reference. Here I'm going to choose PatMax pattern and hit Add. And I get two boxes on the screen. One is my model box. This is what I'm going to look for. The other is my search box, where I'm going to look for it at. Now I could choose one of the numbers up here on the case because these have already passed inspection from the station ahead of us. But I'm going to choose this little dog tooth area down here at the bottom with these couple of little indentations. And I'm going to use this as my locate tool. This is what I'm going to be tracking with and have all of my other tools track with, so as my part moves around, I'm able to find it. So once I get my model box of what I'm looking for, my search box, where am I looking for it at, set, then I'm going to hit the OK button and be able to activate those. Now you notice we have our feature that we're looking for here from one image to the next. And I'm going to name this tool Pattern 1. This is my locate tool. I'm now going to come under Inspect Parts. Very first thing I want to do is I want to be able to count the number of drill bits that we have here. So if I go under my counting tools section, I'm going to open up my counting tools, and I'm going to choose the tool set called Edge Pairs. So I'm going to look for a pair of edges. Every pair of edge will make up one part. So now I'm going to hit Add, and I get a box on the screen. And I'm going to take this box and I'm going to drag it across all 7 drill bits. And as soon as I hit OK, you'll notice in my tool palette in this upper right-hand corner, I'm instantly counting 14 parts. I've only actually got 7 bits. So what's going on? Let's take a closer look at it. So as I'm looking at edges, I'm just going to zoom in on this first part. And you'll notice I'm finding the edge on the outside of the bit, finding another edge, the edge of the glare coming off the top, finding another edge on the other side of the glare, and another edge on the outside of the bit. Well, a couple things going on. If you did watch or were with us at the beginning of this series where we covered lighting, I could add a polarizer or something to deal with the glare of this part to eliminate the glare to just get the outside edges. However, not every part is going to allow itself to be set up with the absolute perfect lighting conditions. Sometimes you have to deal with inspections with an imperfect lighting setup. So let's work with these images the way we have there. Now, the fact is every bit does glare on the top, and that glare really I would expect to be consistent one part to the next every time it goes through. I could literally say that 7 bits does create 14 parts. If I only had 6 bits, it would only create 12. I can still make a good decision off that, provided my results are consistent. And by testing enough parts, I could verify that. However, we can get this to say just 7. But you have to think about it a little differently. And the way I was starting off in my career working with vision systems, and I was actually trying to solve this exact problem, more senior guy came to me, made me feel a little foolish by saying, sometimes you just need to think about it differently. Instead of looking for the part here where we have a white background, if I move up in the area to where my background is black, now I want to go under the settings of the tool and I want to change the edge transitions. And if you have already been with us or had watched our previous video on edges, this arrow for the point of origin tells me my tool is processing from left to right. So instead of looking for a light to dark, dark to light, now I want to look dark to light, light to dark, because I only want to count the tops of the glare because there's only one for each bit. And you notice now I have green edge lines on each bit. And if I look under my tool palette, I'm now counting 7, which is correct. But my tool is red because a counting tool will set as its range whatever it is counting when you first put the tool down. So if I come under my tabs for my range limits, you'll notice that my min and max is set at 14. That was what I count when I first put the tool down. I'm going to reset those to 7, and now my tool passes. I'm now counting 7 bits. So we're now counting 7. I'm going to click through a couple images and make sure that my counting tool, my pattern tool here failed. So let's adjust the pattern tool. I'm going to come under my settings. I'm going to lower my threshold just a little, and now I found my pattern tool again. Next. And I seem to be tracking, and my edge count tool seems to be working without a problem. So I am happy and satisfied. So now we want to move on. We want to actually measure these bits to make sure that we have the right bits in the right location. So under the Inspect tool, I actually now want to go under Measurement. And under Measurement, I want to grab a Distance tool. And I'm going to hit Add. The Distance tool becomes very useful. So the Distance tool will take every contrast edge, everywhere there's a change of feature, and it's going to turn it into a hyperlink I can now select from. So with this hyperlink, I can now choose the left side of this 1/16 bit and the right side of this 1/16 bit. And it automatically creates 2 edge tools and a distance tool. And it's now measuring that bit at 20.455 pixels. Isn't that wonderful? Well, the problem is, how big is a pixel? We don't actually know yet. We need to teach the camera how large a pixel is. So we need to calibrate it to a series of real-world measurements. Now, in the real world, we typically recommend using a calibration grid, But in the purpose of the emulator, we're going to have to use a feature that already exists within our image. So here's how we do that. We're going to come back under Setup Image, and you'll notice in the middle, we had this option we haven't used before called Calibration Type. So this calibration type, I'm going to change on an edge-to-edge calibration. Now I'm going to use 2 edges within my image to perform the calibration. If I was doing this live on site with a live camera, I typically like to pull out my calipers, dial in a dimension, put it underneath my camera, and I would calibrate off that because I know that would be a more precise measurement than what this is. But for the purpose example of how the software works and how the tool works, it doesn't make a difference for what we're trying to accomplish today. So with this, I'm going to change my units from millimeters to inches because we are working in imperial units. And I'm going to say 0.125. We're actually going to use that 1/8 inch bit to calibrate on. So now I'm going to say select edges, and I'm going to choose the 2 edges associated with the 1/8 inch bit. So once I choose my edges, I have my unit, I have my dimension, I hit calibrate. And as soon as I calibrate, the calibration's performed, we know how large a pixel is, and now we're measuring 0.06 or 0.066 inches. So our units change. We're measuring in real world. Isn't that wonderful? Well, it would be, but a 1/16 inch drill bit doesn't actually measure 0.066. So let's see what's going on with this. So I'm going to zoom in right here where our measurement's going on. And we notice we got a couple things going on. One is one edge tool found the correct outside edge of the bit. The other one found the edge of the glare. We're not actually finding the correct edge. Then we're also going from the midpoint of where this edge was found to the midpoint of that edge. So we're measuring at an angle. That also throws us off. So we can actually adjust this. So I'm going to zoom out just a little. I'm going to highlight the Inspect Part tab, and I'm going to choose Edge 1 from my tool palette. So here's Edge 1, and I could make this a little longer if I wanted to. But the key thing I want to point out here is remember our arrow down here, referencing our point of origin. In this case, this is going from right to left. So that outside edge, if I go under settings, from right to left, is an edge transition that is dark to light. It was already on that edge, so you didn't actually see anything move. If I go that same logic now for edge 2, and I change edge transition dark to light, you notice now my edge jumps to the actual outside edge of the bit. So now we're getting the correct edges. But we're still going from the midpoint of one to the midpoint of the other. It's still measuring at an angle, which throws off our measurement. So in this case, I want to choose the distance tool. I want to go under the settings for it. And instead of midpoint to midpoint, I actually want to choose midpoint to line. So now I'm coming 90 degrees off the side. I'm going from the true outside edges, and now I'm measuring 0.062. which for a 1/16 bit is 0.0625 inches. So we are measuring what we need to have. So I'm going to zoom back out, and now all I need to do is all of this to all the rest of the bits. Well, that's a lot of selection and a lot of mouse clicking. Don't you want to know that there's an easier way to do this? Well, there actually is. Previous example that we worked with, we copied tools. But I can't copy multiple tools at once unless I put them in a group. Now, we just covered this on the previous example. We go under Math and Logic, and I choose my group tool and hit Add. Now I can create a group, and I want that group to consist of Edge 1. I want that group to be Edge 2, and I want it to be the distance tool. Now those 3 are associated in a group. Now I'm going to name the group. It's going to be group 1-16. Oh, sorry, can't use a dash. So I'm going to have to use an underscore, group 116. Now with that group being created, I can take that group and copy it and then paste it. And it will paste the entire group. Not only does it get the entire group, it also gets all of the changes, all of the dark to light, light to dark selections, all of the midpoint to line versus midpoint to midpoint. They're all there. So now I can just drag these boxes over and put it on my next bit. You notice this one gets kind of confusing with all the graphics of the one behind it. If I go up to my toolbar, you'll notice this one that looks like two mountains with the graphics behind it that say show selected graphics only. If I highlight this, it turns off all the graphics except for the tool that I'm working with. Now when I choose Edge 3, I can work with just that and get the next one. And you notice here now my distance is measuring 0.077. 0.077 or 0.078 is the actual dimension of the 5/64th. With the resolution camera that we're running and the fact that this was not a telecentric lens, we're within 3 decimal places of being accurate. So 0.077 is acceptable. But you notice we're red. Our distance tool, remember a distance tool is going to put in whatever it first measures when it puts down. I'm going to reset my limits and now my tool is green. And I just realized my first group up here, I forgot to do the same thing with that distance tool so that it's green. And now I'm going to come back to this next group, and instead of 116, this is going to be group 5_64. And what I'm going to do is I'm going to keep doing this for the rest of the groups. So I'm going to copy. I'm going to paste. Now I can grab in this next group, which is going to be 3_32. With that, I'm going to grab edge 5. I'm going to move it over here. And edge 6. And move it over here. And my distance tool. And reset the limits. And what I'm going to do is I'm just going to keep going across. And I'm going to make this window just a little larger so I can see the names a little easier. Copy, paste. All right. Edge 7. Edge 8. And my distance tool set limits. And rename this group. Copy, paste. Now, we use the 1/8 bit to do our calibration, but that was just the calibration. That wasn't actually setting up a tool to be able to run the inspection with. So we still need to do the 1/8 bit coming up. 1_8. And I'm going to choose edge 9. And edge 10. And my distance tool set limit. Now you notice I'm only renaming the groups. That's because within that group, I only have 2 edge tools and a distance tool. So if I'm in that group, I know that those tools are associated with that bit. Depending on your job and how you're setting it up, you may want to do a more detailed job of naming those tools to fit your application. 5_32. And this is a little monotonous or a little repetitive, but it is definitely much easier than having to manually select all of the different changes and all of the differences that we had set up in order to be able to move through this. So one more right quick, paste. All right. So we're going to call this tool group 3_16, edge 13, edge 14, and the distance. All right. So now we have all of our groups, and by grouping it, it makes our job over here in our tool palette look very straightforward. I'm going to turn all of my graphics back on so we can see everything. I'm going to just scroll through some images, and you notice indeed this one right here. So group 532 failed. I'm going to take a look at it, and we're measuring 0.110. We're finding the right edges, so this is a bad bit in that position. Next one over, everything's good. So we are finding the images that do have the incorrect bit in that location and passing the ones that we need to pass. So as I said, we were going to do this more as a complete job build. So real quickly, I'm going to go under communication. I'm going to add a device. In this case, I'm going to add a PLC. This PLC I'm going to choose, I'm going to use Rockwell for an example with the protocol Ethernet IP. And just to let everyone know, tomorrow we're going to be doing a webinar on how to set up RS logics for EIP communication to actually handle the PLC side of the communication between that PLC and the Cognex camera. And then in a couple weeks, we're going to be doing a session on how to set up communication between Cognex and UR robots. So please stay tuned for other communication level workshops as we move forward. So I'm going to hit OK. This tells me that we're changing to match the configuration of Ethernet IP, which is what I want. The protocols have been changed, and I say OK. So now my Ethernet IP is turned on. So in order to get this data to go out, there is an ESD file for Ethernet IP, GSD for Profinet, and the appropriate documentation for the other common Fieldbus protocols out there, and that is in the Cognex documentation in the help file. I'm just going to come to Format Data. I'm going to say Add. And from this, I can now pick and choose what I want to send out. So let's say that under the job, for instance, I'm going to come under Job, and I want to say, what did I fail? And pass. So now I have my pass fail. Now I could say add again under distance, and I'm just going to say distance 1 distance. So now we're sending out 0.062. We're sending out our bits of pass and fail for our job pass, job fail scenario. And this is all I need to do to be able to set up those tags to be able to share with my external device. So now that we have the job built, I could come under the film strip and choose how I want to record images. I have the ability within the camera to be able to record pass, fail, or both. And the new camera series from Cognex, if you're using one of the new ones, does have an SD card slot. So I can put an SD card in and be able to extend its memory, and I can be able to record until that memory fills up. That's what allows me in this film strip to work either off images that are saved from the sensor, meaning the camera, or the PC coming from my PC on the library of image. Once I set that up, I can come under the Save Job. Two important things to note here. Save Job. Save and Save As work like any other save and save as. Save the job under the existing name, or Save As to let me change a name or location. Startup. If I want the camera when it turns on to automatically load a job and start in online mode, this is where I would navigate to be able to choose what job do I want it to load on startup and to start the sensor online. So if you're going to send the job change signal from a PLC with a PLC command, you don't need to worry about this. If this camera is working independently, say it's firing a reject cylinder directly with no PLC communications, you definitely want to have a startup job here. Otherwise, when the camera turns on, it won't know what to do and you'll have to manually start it up. The sensor maintenance, the backup and restore. This is important. When you get your camera online, there's enough memory, you might have 80 or 90 different jobs on that camera potentially. There's an IP address setting. There might be network protocol settings, firewall settings that all need to be set. If you do a backup, it backs up every job on the camera and all the settings associated with it. So now, pretend at 3 in the morning, storm comes through, lightning hits the plant, camera gets damaged due to the electrical spike. You pull a replacement off the shelf. Instead of having to reprogram and reset up everything, you can restore the backup and it gets all the IP addresses, firewall, Windows, TCP/IP, FTP communication settings, and all of the jobs that were there as current as the last backup. So I highly, highly, highly recommend make sure you keep a good backup of your cameras online. Once you're done, then we can actually come under the run job. And with the run job, this is where if I was working with a real camera, I would then put it online, start getting results. But now you can see within my film strip, my play button becomes active. So now within my play button, I have my images that are coming in. I'm getting my number of passes to triggers, my number of fails to triggers, how long it took each tool to process by my computer on my laptop, what tools are being run, and the pass and fail. I can even expand these out to be able to see the details of how long each individual tool takes to run. If I want to clear my pass fail counts, I can restart over from 0, and I can sit here, watch my job performance on either a library of images, or if this was a live camera, I could be watching the data come in, see how well they're performing, what tool might be taking longer that I want it to be able to point out how I can optimize it further. So that being said, that is a complete job build. I know that this last section we've had to the workshop today has been a little longer than the other two. I want to thank you for your patience there. As we're winding up, if there are any questions, please feel free to put them on the chat board, or you can email us at info@acs-ga.com. Now, the other thing I do want to point out is for all of you who would like to keep up with what we have being offered, if you go to our website, you can see a list of our upcoming training webinars. So you can see here we have our Allen Bradley to PLC communications that's happening tomorrow to be able to register for it. The new Cognex ViDi deep learning algorithm is coming up on May the 5th. And then we have webinars that will be coming out for a detailed lighting workshop, UR to Cognex communications, as well as other features as they come online. So do check here, check out our training schedule on a regular basis, and would love to have you attend a future webinar with us. If there is anyone within your facility that should have attended today and didn't for whatever reason, or you would like to view any of these videos as a refresher, all of them are going to be posted onto our YouTube channel that you can be able to reference. Please like us and follow us there as well. I want to thank everyone for attending today and being a part of this. If you have questions, I didn't see any come in on the chat room, please feel free to reach out to us. And I want to thank you for your time and let us know how we can help you with your next Cognex installation. If we can test parts, provide any lab analysis, lighting studies, we'd be happy to do so. Thank you so much and have a great day, everybody.